So in this differential equation question, we have a snow sledge, which is on a smooth horizontal surface. Now the question says that a resistance force, so against the direction of motion, all resistance forces are against the direction of motion, of magnitude 2v squared. There is no mention of a forward force, so nothing is pushing it, it's just sliding and slowing down, eventually it will stop, and we know that the mass is 4 kilograms, so the weight is 4g, and we have a reaction force from the ground onto the sledge. Now this is moving in this direction. So we're going to go ahead and use Newton's law, sum of F equals ma. Forward force minus backward force equals ma. We have no forward force, so we only have the backward force. The mass is 4 kilograms, and another way of writing A is dv over dt. Divide both sides by 4, you get minus 2 over 4 v squared equals dv over dt. That becomes a half. Now divide both sides by v squared and multiply both sides by dt to separate the variables. Like I said, that becomes minus a half. The dt goes up here. Multiply both sides by dt. Then divide both sides by v squared. So we get 1 over v squared dv. You have now separated the variables. So v is on one side, t is on the other side. Now, in order to integrate this, this is copy-paste, nothing changes there. But what does change here is v, integration of v minus 2. We don't need ln, you only use ln when it's v, or it's like a fraction with a plus or minus there, where we have to do the rule in the last question, where the top has to be differentiation of the bottom. Here we don't need any of that, we just make it minus 2. Let's go ahead and integrate, so I'll do that over here. This becomes minus a half t. Add 1 to the power, divide by the same number, plus a. Clean that up. Another way of writing it is equal to minus 1 over v plus a. Now, let's find a. It says here the initial velocity of the particle is 5 meters per second. Ignore that one. That's a mistake. Now, if the initial velocity of the particle is 5, then therefore when t is 0, v is 5. Plug them in, find a. 0 equals minus 1 over 5 plus a. Now, therefore, a is equal to 1 over 5. Now, once you have that, plug it back into there, so we get an equation that says, which is known as the particular solution, minus a half t equals minus 1 over v plus 1 over 5. Move this there and that there, everything becomes positive. You get 1 over v plus equals a half t plus 1 over 5. Make these the same fraction, or you could immediately flip v on that side. I prefer to make these the same fraction, so it becomes 1 over v equals. To make these two the same denominator, they both have to be 10. To make that 10, it's 5 over 10. And this here is going to be, if that's going to be 10, it's going to be 2 over 10. That allows you to combine these two, so it becomes 1 over v is equal to 5t plus 2 over 10. Now you can just flip both sides, so reciprocal. V is equal to 10 divided by 5t plus 2. Now you can go ahead and find the time or the velocity at any time. Now the velocity will never be 0, so the boat will never stop in this case due to the model. And the reason for that is if you try and find time when velocity is 0, if you put velocity is 0, you get 0 in the denominator, which you can't have in maths. So on the graph, it'll be an asymptote. It approaches the x-axis, which is the time axis, but never actually reaches a value of v equals 0.